Okay, looking at a loan problem with equity. This time it's going to be a car equity and the loan. So just make up some numbers. Say you buy a car with a value of $40,000. So getting your cool dream car here. And they give you a 6-year loan at 4% interest. And research is that these type of cars tend to drop 30% in value the first year and then 20% every year after that. How can we look at the equity in different years? And maybe the question will ask you the equity after 3 years or 5 years. We're going to assume you borrow all the money for the car. Now I've drawn in a poor graph, and if I had more time I'd make one on Excel that would be more perfect. That kind of supposed to show the two things that happen over the loan here. So initially the car is worth $40,000, but its value drops, and its value is this line here, which will asymptotically head down to zero, but very slowly towards the end. The loan value, on the other hand, an amortizing loan drops, and it drops a little faster towards the end, and it's going to hit zero. After your last payment on the 6th year, you've paid the car off. So we have a loan value coming down. Equity drops fast, the value of the car drops faster at first. At some point after they cross, this may not be perfectly accurate, but we know it's going to happen. At some point, eventually, the car's value will be higher than the loan. So in this area here, you have negative equity. You have a loan balance that's higher. You owe more than the car's worth, so it would be very difficult to sell it. You'd have to pay money to get rid of the car. Eventually, you could just sell it and pay off the loan and walk away. And then if you keep it long enough, of course, the loan goes to zero and the car's still worth something. So how we calculate the numbers that we would use to graph this one are actually quite simple. This is just an interest rate drop. If it loses 30%, it's worth 70%. So 0.7 times 40 would be 28,000. Put a K to indicate 1,000. To get the next year, you would multiply by 0.8, and I got 22,400, and then so on down. And I think I put year 5 here for comparison. $7,000. Rather $11,468 for the value, and then the loan's going to turn out to be $7,000. Now, how we calculate these loans? We go back to the calculator here, looking through the iPad as I try to figure out what I'm doing, and I press Apps, Finance, Time Value of Money, and we'll be off and running. So we have a 60-month loan. Oh no, rather it was 6 years, so it was 72 months, and I'd already calculated the payment. So to show those steps again, I would turn this into 72 months. And bear with me a bit as I just work here. And the future value would be 0, and we calculate the payment for this scenario, $625.80. So it's the number that was there. Now, if you want to know how much is owed at any other time in the loan, you put in the appropriate number of months. So for 5 years, it would be 60 months, and we go to future value, alpha solve. $7,349. If you wanted to know what you would owe in at the end of the first year, 12 months later, the future value. So we have $33,900, and we see that the negative equity that we mentioned here would have certainly happened. You owe $33,000, the car is only worth $28,000, so you're around $5,000 upside down on the car. When questions ask equity, you subtract what is owed from the value. So in this case, the answer would be negative $5,000 and some odd dollars. And then eventually the equity would turn positive. So I hope this video helps you understand car equity and loans for your homework and for real life as you think about purchasing cars someday.